In this HVAC training video, I'm going over all of these Hilmor sheet metal tools. I'm taking each one out individually, going over their name, their purpose, and also using each one on sheet metal. So I want to start off with these basics, and so these right here are 3-inch aluminum tin snips, and these are made for cutting longer lengths of straight sheet metal. And so they have blades that you can replace. Here you have tinner snips. These are also typically referred to as 3-inch long tin snips, and so both of these are used for making long straight cuts. Now over here you have what's referred to as tin snips or aviation snips, and so this one right here, you're going to notice that this mouth, it faces the same direction as both of these. Same thing with the yellow ones, but the green do not. And that's because the green are made for right-hand cuts. So right-hand circles or turns, and so these ones right here are made for short straight cuts. And this one right here is made for left-hand cuts because this mouth goes underneath of the sheet metal when you're cutting, and you're able to turn very easily with this. And so most of these tin snips are faced with this kind of like left-hand facing bottom mouth. Even if you are cutting straight, this one, and this one are typically all going to have that one down in the lower left. And so this is not made for a left-handed person. It's made for a, right-handed person or left-handed person, doesn't matter. But these are typically called left-hand cut tin snips, and these are called right-hand cut tin snips. So I'm going to give you a demonstration on each of these. So right here, we are going to take a cut on our flat sheet of metal. I typically put my finger right in here. And so my fingers don't tend to fit all the way back here too much. I just like to kind of have this a little bit more control. And so oftentimes I'm doing this, if it's a long sheet, maybe it's on the ground at a job site. And so what I'll do is I'll lift this little sheet up right here. And you always want to wear some type of gloves to avoid end up getting those little barbs stuck in your fingers. And so gloves are there to end up protecting you. Now here's the issue with tin snips. What you don't want to do is close down all the way. That's how you make these sharp barbs, and I'll show you what a sharp barb is right here. So right here you can see that. You do not want that entering into your skin. And so I'll just bend that until it pops off just to get it out of there. And so when I'm making a long cut, what I'll do is I'll pull back like this, or I'll lift up. And of course, this is a tiny little sliver, so it's really easy. But if it's a big sheet, I'll still kind of pull up and away from the tin snips. And that's also going to force your tin snip forward. And so you're just going to kind of cut a little at a time moving forward, just like this. So same thing with these right here. I would use these just for making straight cuts. Of course, I have no line marked on here. I'm just kind of like eyeing this up. And so it makes a smooth edge on here, and that's why you would typically use these over trying to make a long straight cut with your smaller tin snips. And so if you want to make a cut with your smaller ones, it's going to take a longer while. These are made for cutting on an angle. And so I'll go ahead and mark a circle, and I'll go ahead and cut it out with these tin snips. In order to show how the left hand and right hand cut tin snips work, we're going to trace a duct collar. And so that's what we would do out in the field to cut a round collar into a piece of ductwork or a flat sheet of metal. And then we can take a duct slitting tool, which is basically like a flathead screwdriver and a hammer, in order to go ahead and make our first hole. As you can see, my metal is moving because it's just a small piece. If this was a duct, we wouldn't have that problem, and you could always hold on to it with another hand. So basically with your duct slitting tool, you're going to open this crevice up, and that's going to be your first hole for using your tin snips in order to make a round cut. Now another way to do this is with a step bit and a drill. And so we can just go ahead and do that now. I'm going to put this on number 1 so it's a little bit stronger. This is a a very small drill. So there we have a bigger hole that we can go ahead and start with. So either way, as you can tell, this really throws a lot of shavings around. So we'll use this, which is our left hand cut tin snips. We're gonna start by making a little hole. We're gonna come back around and we're gonna swoop around over to right to where we started at. So right on our black line right here. So you just kind of make a circle and kind of come around over to your black line. Remember not to fully close these because that's how you're gonna make barbs. When I'm training students in the classroom, what I have them do is I have them utilizing these tin snips, and they might make like 10 circles, and I don't wanna see a single barb in them. Basically, they gotta get to the point where they don't have any barbs, and then I know that they have that skill down. All right, so here with our right hand cut tin snips, remember right, we can go that way. So just to show you what that looks like, so we can just come right in here like this. Now you're gonna notice right now, it's binding up a little bit because this metal won't fold up naturally. That's why we make kind of like a semicircle to give us more room to have the metal fold upwards. So sometimes it looks like it's a little bit extra of work, but that's why we're doing it. So you can go both ways. Obviously, you do not need both of these tin snips to cut one circle. You would just go ahead and cut it with the one. And you would just move around as you go. I'm cutting on the outside, making that line disappear because we mark the collar on the inside. Once again, I'm just showing you how to utilize these tin snips. You can cut backwards like this with your hand or forwards. And so these little things right here, basically you're pressing forward, and so these are allowing you to be able to move your tin snips inwards without slipping on the grip. And so same thing when you're doing it backwards, this is where I end up working at like that. So now we went over the left hand cut tin snips, the right hand cut tin snips. You can see L right there, and you can see R right there. Your duct slitting tool. We went over the use of a step bit. And just so you know, since we're on this topic, what I'll do is I'll just go ahead and bend these inwards in order to set this in. So basically, you're gonna bend all of these inwards a little bit. When you trace this, you wanna have all of these collar tabs straight so that you have the correct size hole. So if these were bought from a manufacturer, you could always kind of keep your same hole size. But if it's not, and you're making these at the shop, they might vary a little bit. So what I'm gonna do is I'm gonna bend this one, and I bend one over on the other side, right over here. And then I bend one in here. Bend one in here. And so as you can see, we're gonna keep bending all of those in. And if there's a way for you to like beat these inwards in with a hammer from the inside, you're gonna close this little seam right here to avoid a duct leakage. And this is where you would put your mastic on afterwards to seal this joint. Now I just wanna show you that you typically are gonna buy these in a set. And so it might be a 3-pack of aviation snips. The reality of it is, at least for me, I don't usually use these unless I'm cutting something that I don't really care about, you know, like damaging the blades or something like that. These blades, by the way, are made for sheet metal. Do not cut wire like flex wire because you will destroy these. And I would never use these to cut something like that, but these are straight, so I can't turn very well. And because they're extremely straight, it's gonna put me right into the bite of the sheet metal. I actually wanna be up a little bit with my hands up. Now, as you can see with this, you can see it's straight. This is slightly offset, so you can see kind of there's a bend upwards. So this gets your hand out of the, say, the sheet metal bite, so you're gonna be up a little higher. Hilmor also has these offset tin snips, so it gets you even higher, up out of the bite. And this is going to allow you to not have to pull up on the metal as much as you're cutting. And so it's going to get your hand very high. So this is also going to allow you to get around, like, say this is up in between a joist bay. you're going to be able to cut and swing as you're coming around this without hitting maybe a joist. Whereas if you have snips like this, you're going to see the end of the tin snips kind of comes out a lot farther as you're going around. So you have to have more space around the object that you're cutting with regular tin snips or regular aviation snips than you would with something like offset tin snips. And so this right here, since it's green, this is the right hand 90-degree offset, and this right here is a left hand. So that's a full 90 degree, but these ones are going to get you basically pretty much there. So I like this just to be able to kind of maneuver around a tight space. So you have the left hand offsets and the right hand offsets. So right hand cut, see R? So this is S-lock slip or slide. So basically there's 3 sheets of metal here. When you're cutting through that, you don't want to use your standard tin snips, you want to use something that's made for this. So these are called bulldog snips, and this is going to avoid not only making these less sharp in here, but also avoid the possibility of breaking these. Bulldog snips, you're going to be able to apply a lot more force, and it'll be easier on your wrist and hand as well. Now let me show you a quick trick for doing this. As far as applying force goes, if you are able to set that bottom handle down and press downwards, it's going to allow you to press downwards with less force, as you can see here. So I really prefer anytime that I have to press downwards, basically what's going to happen is I will always set that thing on the table, that bottom handle. But you can do this without it too. So as you can see right here, just like that. If I don't have bulldog snips, this is an instance where I might use something like these yellow ones, but I will not be pressing very hard at the very tip, because I have seen this break off, literally break right off and shoot, like hit the wall and bounce to the ceiling and stuff like that, and you always want to be wearing safety glasses. So I might press down a little bit, and then I'm going to come in and I'm going to be applying force on the back part, back here. So I'm only going to be on the back part. So only back here. And so that's something that I might use these for if I don't have my bulldogs. So this right here is S-lock. You can see 3 pieces. Here you can see basically it's almost 2 pieces. This is drive. So this is S-lock slip, slide. You could use any of those 3 terminology for that. And this is drive. And so drive is used to put ductwork together or to hang ductwork, and this is used to connect 2 pieces of duct. So if you think about it, what's happening is you're just slipping this in on one side all the way, and then you're slipping your other piece of metal inwards like this. And so it's connecting. And so you would be using a larger piece of S-lock to do this. And so the best way is to just use regular bulldog snips or even regular tin snips to cut through your drive pieces. But this isn't as big of a problem as cutting through 3 pieces of metal with regular tin snips. So in reference to using bulldog snips, right here we have a Pittsburgh lock that's already put together with a duct, and if we want to cut that down, we have 4 to almost 4.5 pieces of metal right there that we're going to have to cut through with a single stroke. So we were going to go ahead and start with our left-hand cut tin snips. So I'm going to stop right there. Hopefully you can see that. We're going to take our bulldog snips and we're going to finish cutting this last portion right here. We're going to come to the point where we can start cutting straight down through all of that. So that's another use for the bulldog snips. The next tools we're going to go over are the 5-blade crimpers and also the 3-blade crimpers. So both of these can be used in order to crimp one sheet metal tube in order to fit inside of another one. And so as you can see, this is not going to be able to be connected, and so we need to crimp it inwards. And so I prefer using the 5-blade crimper. In order to get it to bend inwards, you're going to have to put the 2 blades on the inside. So just like this, all the way around. Now another way to do this is, like I had mentioned earlier, what I prefer to do is to just take some of the pressure off of my wrist, and I like to put this handle down onto the table. We might be working on the ground, wherever we're working at. This is going to allow you to get a very deep crimp. This over here is taped. In the meanwhile, you can also mastic that. And so we can place this over the other one. Next, in order to screw this together, we've got a reversible magnetic nut driver. And so you can see 5/16 right on the top, and we can change that right over to 1/4 inch. And then we can take our screws right here and then put that right in there and use them to connect our ducts. You want to make sure to place your finger. If you can get your hand in, you want to definitely get it several inches back further from where you're going to be screwing at. We are going to want to make sure that this does not have any air leakage later. We're going to want to put some mastic here. Thing is, if you have a bunch of screws, you can go ahead and pick them up just like that and turn it. Get the screw ready. The least amount of screws that you would use on this would be 4, but the more screws, the more tighter it's going to be, especially in that seam area right here. I mean, technically you really don't need anything right here, but I'll just put one. So the air would not be going this way. It would be going this way. And as you can see, we actually crimped it a little bit too much, but we had absolutely no problem coming into it, and it is tight. Over here is where the little gaps are going to be. We're going to need mastic or tape that has mastic on it. And so our airflow is going to be coming from this way going through. The next tools we're going to demonstrate are the folding tool, the advanced folding tool, the snap lock punch, and also the pocket brake. Now we're going to make an end cap here without any slip or slide and without any screws in order to lock a cap onto the end. Now this sheet of metal right here is 1 3/4 inches longer total than this length. So this is 14 inches, and so this is 15 3/4 inches. And so right here, this is 8 inches, so this is 9 3/4. And so the first thing that we're gonna do is we're gonna take on the edge of this, we're gonna take our tape measure, lock that 1 inch, and we're just gonna scrape it. And so that's gonna be where we're gonna cut out a piece of metal that'll be a little bit bigger than a 90-degree square. So we're gonna have to increase that angle maybe to like 110, 120 or so. And so we're gonna remove this little piece of metal. So we're just gonna spin this around real quick. This can be done by eye later if you know, you kind of understand where 1 inch is. You can kind of eye that up, but I just wanted to just mark it so you're aware. The other thing is, do not keep twisting these because you'll end up with a curlicue or like something like that. You just want to bend it back and forth until it pops off. So the next thing we're going to do is we're going to use the pocket brake. So you want to have this on wood or cardboard or something so it gives a little bit. We're going to place these wheels on the sheet metal. You can trace this out with a Sharpie ahead of time, or you can just kind of eye it up in order to make a scrape basically in it. So what that's doing is it's going to allow the metal not to pop when the duct ends up getting pressurized. So it's not going to be able to pop. You're going to have positive pressure in the supply duct and negative pressure compared to atmospheric, you know, in the return duct. So the next things that we're going to do are we're going to bend these pieces in by 3/8 of an inch. And so we can do that with our folding tool. This is our standard 3/8, and 1-inch folding tool. We're going to put a piece of wood underneath of it so it's rigid. So when you're bending this, you need to have something firm underneath of it. And the whole point of that is so that you can kind of make a nice crisp bend. And so you can see the metal in both of those diamonds right there. And we're going to be folding this inwards with this point down. So this has to be bent in a way where this is pointed in a downwards manner. We're going to fold this completely over. And then I like to take hand seamers and just snug this down a little bit. And so I like to put my one part of the handle down. And that's going to make a nice tight hem, just like that. Now over on this side, we don't have to use an 18-inch folding tool. We can just use a smaller one. So this right here is a 12-inch folding tool. These come in 12, 18, and 24-inch. And so we're just going to put this in here. You can see the diamonds, you can see the metals in there. So hand seamers can come as 6-inch or 3-inch. And they may come as straight or offset like this. So these offset 3-inch hand seamers. And just so you know, we'll be getting into these in a little bit, but basically this is 1/4 inch, 1/2 inch, 3/4, 1 inch, 1.25 inch total. And so you can kind of utilize these to help fold over bent hems and bent seams that you use with your folding tool. And as well, it can be done, used as a replacement for your folding tool if the section that you're trying to bend is very small. So now that we have this all bent, we're going to flip it over so that the point is now sticking upwards. We're going to be using our advanced folding tool. Now this is the tool that we invented at acservicetech and that Hilmor now has and produces. And so this is a wide gap, and the whole point of this is to be able to bend folded over seams. So you can see it fits right in there. And so you're just going to bend this up, and now this is what's going to ride onto your duct and connect in. So this tool was developed to be able to make plenum end caps, duct end caps, and also it can make a modified Pittsburgh seam. So we have a whole nother video on this tool linked down in the description section below. In the past, we've had to do this with basically just handbrakes, and that was a tedious thing in order to try to bend something like this. Now that we have this all bent, we're going to open up the seams, and so you'll open up every single one of these seams here, and you're going to be using this duct slitting tool in order to do that. Now you can see that this fits in here. It's a little bit smaller, and that's because of that 1/4 inch, and that's very important because you have these Pittsburgh seams in the corners. You don't want to have this end cap be too tight. We're going to be locking this in place with our snap lock punch. So that's going to go over this and it's going to lock it. Now we're going to take our end cap, which should be a little bit smaller than the inside diameter. We're going to put it on just like that. We're going to do one part at a time. So we're doing the top first. So you can hear that kind of like click noise. That's it penetrating. So let's just get this side on first. So now that we've secured this all in place, what we're going to do is we're going to take our handbrakes, or our hand seamers, I like to call them either way, and we're going to go ahead and tighten this down. So we're tightening all of these seams. So I squeeze this, and then I pick up on it, and that's going to close that seam right here, right on the edge. This is the same process you'd use for a plenum end cap. So that's how you'd use a snap lock punch, a 6-inch hand seamer, or a 3-inch offset hand seamer. You could also use a hand seamer like this, where you're slipping it over a piece of metal. So say you want 1/2 inch, you can just bend it like that. You can get it right on the 1/2 inch marks there and there, and then you can just bend it over so that you have a 90-degree bend. So remember, these marks are 1/4 inch, 1/2 inch, 3/4, 1 inch, and 1 1/4. You also have your pre-made measurement, which is 3 inches right here. And so if we wanted to bend this other part of the 1/2 inch here, what we could do is we could take our 6-inch hand seamers and we could set it right on the 1/2 inch mark, which is 2 marks from the end, and we could fold this upwards. Now I would only do it a little at a time here because we have a long piece of metal. And so let's see here, right about there. And so that's how you would bend 1/2 inch with your 6-inch hand seamers. So these are your straight hand seamers, and these are your 3-inch offset hand seamers. This tool right here is a V-notcher, and so it goes inwards about 3/4 of an inch, and say you wanted to just cut out a notch, like a 1/2 inch notch right here for like maybe a flange. So you cut it out there, and then you can cut it out on this side right here. And this is typically used for something like making plenums, and so then you can go ahead and bend it at that area and then fold in your other seams. It's just an easy way instead of using tin snips in order to cut out a small triangle. The next thing I'm going to go over is how to use these 2 folding tools in order to make an end cap for this duct that we can connect using slide and drive. So this sheet of metal already has 1 cross break from this pocket break, and so we're going to also utilize the pocket break again to make 1 more. And so we're just going to line this up. All right, so now that we have our cross breaks in place, we're going to be using our folding tools. So the very first folding tool that we're going to use is this one right here. And so we're going to flip this over so the point is upside down. And then we're going to take our 3/8 side right here, just like this, and we're going to fold up. So now our point is up. So this is our 3/8 side once again. I'm using my hand seamers in order to just snug that down. That cracking is just the cardboard that you hear right there. Now on this side, we're going to flip this over, and we are going to take our 1 inch and fold this upwards. So this point is down right now. We can take our hand seamers. Now this is a 6-inch hand seamer, so this will work pretty well for folding this over. You can see it missed just a little bit right there. For a longer section right here, you could use the advanced folding tool with the large mouth and just fold that up. So now that you have this end cap done, we're gonna slip S-lock, slip or slide, whatever you'd like to call it, right in. So this duct is 14 inches. And so this right here is 13 3/4 for our S-lock. How we do this is we just set 1 corner in, just like this. We set the bottom in first, then we set the top. So hopefully you can see that, and we're going to take our drive, wiggle that on and push it down. Now, we take this side and we wiggle up and down until we get it in all the way over for this side. Take our other piece of drive, slip that down, take our handbrakes and fold that over, or we can just do it by hand right here like this. So there's a lot of big seams on this. Anytime you do an S-lock and drive seam, so you have to put mastic all around this. It's a regular end cap will be a lot tighter that you're using the snap lock punch on. But anyway, those are the main uses for our folding tools. Now let's go over connecting 2 pieces of duct and what the purpose of this is. Typically you don't need a duct stretcher, but this is going to help connect 2 pieces of duct that maybe are not quite aligned properly. So now we're trying to put 2 pieces of duct together, and you can see, hey, they're not coming together quite right. Now the reality of it is that one of these 2 pieces of metal might be longer than what they're supposed to be, and that's what's stopping this from coming together, or the duct might not be pitched properly. So you can really fix that without an extra tool, but if you really needed to just get it together, you know, and you're only like stuck in this position, you can use a duct stretcher. And what this is gonna do is it's gonna take these two wheels behind the ears right here, and it's going to pull them together, and it'll do that long enough for you to get your drive in place. And so now the drive is in place, and then we can go ahead and push that down. So that's the whole point of this. In fact, the other thing that this could do is it could end up pulling this piece of metal over here at the Pittsburgh lock. It could end up pulling it this way. So that is helpful. If, say, like this one right here is not put together exactly right, it's about 1/8 of an inch off, it's possible that this tool could pull that into position. It could just yank that whole thing over. See, as you can see right there, it actually pulled it. So that's how that would work. The next tool we're going to go over is the adjustable hole cutter, and so this has a drill bit right here that's able to drill horizontally, not just downward. And so you're able to make a pilot hole and then rotate this with the use of a cordless drill in order to make a hole in the ductwork. Now I'm going to take you up for an up-close image of this, but basically this one right here can cut up to 12-inch collars, and this one can cut up to 20-inch collars. And this right here is a 7-inch collar, and this measurement here is about 6 3/4 to 6 7/8. And so we have to determine what the radius of this is, but on the tool it makes it very simple for you. So let me show you that. Right down here, this is the inch mark. And so we can go right over to 6 7/8 and tighten it down. So right there, so hopefully you can see that. And I'm gonna finish tightening it with my slitting tool right here. So basically you have a radius that will be perfect for that right here. So you can see that it's exactly where it needs to be. I'm going to show you how to use this now. Now I'm going to go ahead and mark the inside. A lot of times when people are using an adjustable hole cutter, they don't trace it and they just kind of eye it up. But I'm just going to do this to show you how this works. And so we first need to drill a pilot hole. And so to do that, I'm going to line this up kind of backwards. You see this little tip right here is right before the black mark. I'm going to do that a couple times right here. So right here, here to try to get it in the center. So that's pretty good right there. So now I'm going to go ahead and drill our first hole. And then we can take this part and stick it in the hole. Now what's going to happen is, as I drill this, we're going to rotate and we're going to actually fall down into this hole. So I'm just going to go clockwise. So that's it. To test our hole, we're just going to push all of these collar tabs inwards. Should be pretty darn close to what we need. The other thing is you only want to do this on open ductwork because you're just going to have a lot of those little shavings fall into the ductwork and you can't leave that there. So that fits pretty good. And then you just press in your tabs here. And you would do that for all of them. And then you can just put mastic on the outside. And if you're looking for any of the tools used in this video, I have links down in the description section below. And if you want to learn more about HVAC, make sure to check out our new 2nd edition Refrigerant Charging and Service Procedures for Air Conditioning book. And that's available over at acservicetech.com and also on Amazon. Also make sure to check out our Inverter Mini-Split Operation and Service Procedures book. So that goes over the electrical and the refrigerant side of inverter mini-split systems. And also make sure to take advantage of the free resources we have over at acservicetech.com, such as the podcast, the quizzes, the calculators, and also the articles. Hope you enjoyed yourself. We'll see you next time at AC Service Tech channel.